Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Question 10. Solve for y. 2 to the power of 2y plus 1 minus 5 times 2 to the power of y plus 2 equals 0. Okay, so the first step in this one, well, the easiest way of doing this one is to perhaps sub in something for some of these powers and simplify it, okay? So let's have a look at some of the rules of indices and see if we can simplify any of these. So we have a 2 to the power of y, not a whole lot we can do to simplify that one. Is there any way we can change this one to write it in terms of 2 to the power of y? Well, yes, there can. Let me just get the rules of indices here. It's 2 to the power of 2y plus 1. That's what I have. Okay, so the powers are added together. So this looks like it could be a potential rule to simplify it. And I have 2 to the power of 2y here. So there is two terms multiplied by each other. So I could potentially try and use that rule as well. Okay, and that's exactly what I do. I use this rule first. So you see the 2 to the power of 2y. I could write that as 2 to the power of 2 to the power of y. Or of course I could write it as 2 to the power of y squared, because either of them gives me 2y. Okay, because the order doesn't matter in multiplying. And then how do I get the plus 1 into it? Well, there's one base number. I can multiply it by 2 to the power of 1 in both cases. Okay, so that takes a little bit of practice to get your head around. I'm going to do it again in the sum. Okay, let me just copy over these three rules. I don't need the middle one, but it's just easier to copy all three. Let me paste them in there. Okay, so they're the rules from the log tables, page 21. Okay, so I was saying that I have 2 to the power of y here. Would be nice to be able to write this in terms of 2 to the power of y. So using this third rule here, I can write this one as 2 to the power of 2 to the power of y by 2 to the power of 1. Or of course, I could put the y first and then squared by 2 to the power of 1. Okay, which one is better for our case here? Well, this one is actually better, because there's my 2 to the power of y, there's my 2 to the power of y. Okay, so let x equal to 2 to the power of y in this case. So I'm going to use a substitution method, and it might make my quadratic a whole lot easier. Okay, so minus 5, 2 to the power of y plus 2 is equal to 0. So I've just rewritten 2 to the power of 2y plus 1 as this. So I'm letting x equal to 2 to the power of y. So therefore this 2 to the power of y here becomes x squared by 2 to the power of 1 is 2 minus 5 times 2 to the power of y is x plus 2 equals 0. Okay, so I hope that makes sense. This is 2x squared minus 5x plus 2 is equal to 0. Okay, so I'm going to factorize it. If you've watched any of my recordings, ax squared plus bx plus c is equal to 0. I solve a lot of them using the minus b formula. Some of them I solve by factorization. When there's a number in front of the x squareds, I use both a and c for my guide number. So 2 2s are 4. So the factors of 4 are 4 and 1, minus 4 minus 1, or of course plus 2 minus 2. Which row gives me minus 5? That's the minus 4 minus 1. Okay, so I rewrite my quadratic. The 2x squared stays the same. Instead of minus 5x here in the middle, I use minus 4x minus 1x, because that also adds up to minus 5x. Plus 2 equals 0. So the 2 stays the same. So minus 5x just gets replaced by minus 4x minus 1. And then I use grouping from Junior Cert. So group them together, group them together. So what's common in the first two terms? The 2 is, the x is. I need another x left over, minus 2. What's common here between 1x and 2? Well, all that's common is 1. X left over and minus 2. Okay, why minus? Because minus my minus has to give me that plus. The brackets match, so I know I'm good. So the final bit, bring the two outside terms together, which is 2x minus 1. Bring the inner terms together, or just write it down once, is 0. Okay, so let me just go on to a new page for that one. 2x minus 1, this is just where I left it off, by x minus 2 equals 0. So let's solve for x. 2x minus 1 equals 0. 2x is equal to 1. X is equal to a half. Or x minus 2 is equal to 0. X is equal to 2. Okay, so that's that quadratic solved for x. Now, of course, I wasn't asked for solve for x. I was asked to solve for y. So we go back to this substitution that we made just to make our quadratic a lot easier. And we use this. So x was equal to 2 to the power of y, wasn't it? 2 to the power of y. Okay, so let 2 to the power of y so equal to a half, and let 2 to the power of y equal to 2. So 2 to the power of y is equal to a half, and 2 to the power of y is equal to 2. Okay, so again, same page, rules of indices and logs. And we grab these ones. Okay, so when what you need is in the power, like it is for us, you have to use logs. Okay, logs are the opposite of powers, so that is why they go hand in hand. So you can either use the switch here to write it in terms of log and solve for y, or you can use one of these two rules that basically takes log and powers and where they cancel each other out. So I'm going to use this rule here because I have 2 to the power of y. So it's telling me if I do log to the base 2, in this case, in other words, I match the base number. That's your base number, 2 in my case. The base number there and log to the base number will cancel, leaving me with just the power. So what I'm going to do is log to the base 2. And what I do to one side, of course, I have to do to the other, of 2 to the power of y is equal to log to the base 2 of a half. And this base 2 and log base 2 cancels, so you're left with just y, and I have to suffer the consequences of the right. So what I've got here is the exact same answer you will get with the switch. Okay, there's your base number a, that's where I got log to the base 2. Y is your answer, which was my answer in this case. So that's log to the base a of y. Okay, is equal to x, x being what was in your power. Okay, so it's the same thing. So into your calculator then put log to the base 2. So you're not using the log button. Okay, so that button that just says log on its own, do not use that one. That is log to the base 10. Okay, you need to use this button here that's over on the top right with the boxes on it that allow you to put in your own base number. So log to the base 2 of a half is minus 1. And the same in this one, I'm going to do log to the base 2 of both sides, 2 to the power of y, 2 and 2 cancel, log to the base 2 of 2 is an easy enough one, y is equal to 1. So my answers for this one, y is equal to minus 1, y is equal to 1. Okay, a very important question to know how to do for your Leaving Cert. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice? In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.